Hello everybody, this is Walter from WorldCivil. On this video I want to show you how to migrate a vanilla Golang smart contract on Hyperledger Fabric to Convector. It is going to be pretty much a video version of this post in which a few weeks ago I showed how to migrate and create a new smart contract with the new Convector CLI. So what we are pretty much going to do is we're going to take this simple fabcar.go file that comes with the fabric samples repository, and we're going to migrate it to a more robust way to develop with this model controller pattern that Convector brings to the table. So first of all, let's see what we are going to migrate. If you go to the fabric samples in GitHub, pretty much the URL is github.com/hyperledger/fabric-samples. Here you can see this file inside the favcar go folder, in which the Hyperledger team brings this pretty simple example of how to create a smart contract. So if we see the structure of this file, it kind of looks a little bit messy for us, since it includes the model and also the smart contract logic in the same file. So it's obviously not scalable, and it's pretty much locked to this model. So the first structure is this import of some dependencies for Go. We have here the structure for the smart contract. We also have this structure which is called car. In this case, for Convector, this is what we call a model. This is a data structure that needs some rules, for example, data types and so on. We also have a few functions for the logic of the instantiation and the invocation channels and functions for this smart contract. We also have this invoke, which is going to receive each invoke transaction to this smart contract, and it is going to route it to each of the functions. As you can see in here, we have a query car, we also have a create car, we have a query all cars, and a change car owner, which are pretty much all the functions to create new cars, transfer them, and then query. So here you can see the code. It also has some default seed data that it creates when it initializes the ledger. And if we continue around here, we can see all the logic in which create car, it puts all the arguments that comes with the function. They don't really have data types, so it creates this model, and then it goes to the fabric API, which is called stop, and it puts the state. As well, when you query cars, it extracts all the data, transforms the buffer into the data structure, and then in the change car owner, it extracts the data and then updates this property, which is called car owner, based on what comes in the arguments. So as you can see, this is the baseline code that we are going to migrate. So I'm going to show you how to create this with Convector CLI and how we can turn this into a model controller pattern. So yeah, let's go and migrate this Golang source code to a Convector smart contract. First of all, you will need to have Convector downloaded, specifically the Convector CLI. So if you don't have it, just do something like this. You just have to click, you just have to type npm install globally WorldCivil Convector CLI, and it will just take a few seconds, and now you have Convector CLI installed. So you don't have to set up everything manually. It will become a lot easier. So let's go and do conf new. Let's call this project fabcar, and we will create a default chain code that is going to be called car. So let's click on this, and it is going to create a lot of files for me. Some of them will include configuration files like some JSONs, and others will be these specific TypeScript files. So on your source code editor, you have to open that folder. In this case, I have this one. and you can see that this is going to create this basic structure. It includes everything that you need, even the connections and the configuration files for you to install the smart contract. And here we have this bootstrapped controller file, as well we have this bootstrap model file. So first of all, as you can see, there are some dependencies missing, so you have to do npm i, and it is going to install all the dependencies on this project. Yeah, and you have to first get into the folder like this, and it is going to install everything. So while this starts and finishes downloading all the code, I'm going to check out again this favcar example so that we can take a closer look into each part. Convector is based on a model controller pattern, so you have obviously models in one side, and on the other side you have controllers. So we first have to take this structure from Go, and we have to turn it into a model for Convector. So let's go to this file, and I'm going to paste this just to have it as an accessible reference. So yeah, in here we can see that Convector by default brings these properties, which are name, created, and modified. For our case, we don't need them, so we can erase them. So we can do something in here to migrate these properties. So the first one that we need is the mark, the make. So we have to put in here make of type string, and pretty much that's it. We have accessible some decorators for us. So for example, the make should not be changed after the first time you set it. For example, if you are creating a new car, it shouldn't be possible for somebody to change the make. So we can add something in here, this decorator, that is going to set it up as a read-only property. And we also need a few other decorators. For example, we need this to be required. As you can see, as I am adding them, it's going to highlight them since these are properties exported by the Convector core model. So the great thing about this is that I won't have to validate this manually. If the model doesn't meet this requirement, it's going to throw an error for the smart contract. And something extra that I have to include in here, it's the data type. In this case, I'm going to use the job library to make this data type string. So there you go, you have your first property created in here. The installation of the packages is ready also. So we have to create another property. In this case, it's going to be the model. It's also going to be in a string. And I think it follows all these three properties. So I'm just going to copy and paste them. So let's include also the color of this structure. In this case, I think this has to be required, and it also has to be a type string, but I don't think this has to be read-only, because you can change the color of your car and you may have to update this on your registry. And the last property is going to be the owner. In this case, since I am only migrating this smart contract from the Go example, I'm not going to force this property to be a certificate. I'm just going to let it be a string and continue the example. But in real use cases, this should be mapping out to a certificate, because we don't want anybody to just be the owner of car. And we want to validate who is the owner right now to see if they can, for example, transfer this to somebody else. So there you go. We already have in here like that our model. And again, what we are avoiding and what we are achieving also with these decorators is that we won't have to validate things manually, which is really a burden when you are creating code, because if you miss one of these validations, if you code them manually, you will have a lot of quality problems in your smart contract. With this, you just forget about them, and you can be sure that these validations and these rules are going to be set up for you. So now that we have our model, let's clean this referencing here. Let's go to the controller and create everything that is requiring here. Convector smart contract, specifically the controller, looks a lot different from a vanilla Java or JavaScript or Golang smart contract. It looks like this. It's based on functions. It also has parameters, which also have types and some validations. So I'm going to show you how to migrate the logic from Go to this specific format that we have in here. So let's go back to the original file in the repo from GitHub, and we are going to see here that all the functions that this smart contract has query, it has init, it has create, it has query old, and change car owner. So the first thing that I can see here is that this init ledger function, it's going to create some bootstrap data so that I can, have some examples in here. So the way that we can do this, it's simply creating a function in the controller. So on this file, I'm going to create a new async function, which is going to be called init ledger. It doesn't receive any parameters. In this case, it's just including some mockup data. And for this function to be invocable, I just need to literally just include this property. And just like this, with this decorator, I can be able to call this from my code outside of this smart contract. This is important. Any function that includes this decorator can be queried, can become the result of a transaction from the customer. So since I don't want to create all of these manually, all of these examples, what I'm going to do in here is I'm going to copy this mock data that I already had, and I'm going to emulate doing the same as the example from the favcar. In this case, since I already have this structure, what I would need to do is to save every single one of these new cars. So I can do something like this, await.promise.all. I'm going to call every single car in here, and I'm going to save each one of them. So yeah, let's do something like this. I have to map this mock data like this. So what this code is doing right now, it is iterating every single property in here, and it's going to save the data when I call this init ledger function. And that's it. That's all we need for this first function. So if we go back in here, we can see that we also have this query car function. So let's go back to our code and try to migrate this. In this case, it validates, as you can see, manually the amount of arguments. This is what I was telling you before. Since this depends on you coding every validation, you are really prone to errors, to have mistakes validating these things and data types and things like that. So let's go back in here. We have this query function, and we are going to migrate it in here. So let's create a public function that is going to be query. And we have to make this invocable just like the one before. And in this case, it is going to filter one car based on its ID. So I have to include in here a parameter for that. So I'm going to include a param. In this case, I want this to be of type string. So I'm going to validate its data type. And I also need to include the name of the property, and it's typed like this. So let's see. Oops, I missed this one. It should be like this. And there you go. We don't have job imported just yet in here, but we can go in here and we can copy this import. And there you go. Here we have our query function. So pretty much what we have to do is just call the model. In this case, it is a static class of this model. So we can click in here, we can type in here get one, and we can send a parameter in here, and that's it. With this, we are going to the the stop, to the fabric ledger, we are getting one by its ID and we are returning it to the customer. This simple one-liner code is pretty much this part of this Go contract. We still have some properties and some functions that we need to migrate. So let's go back to this code and let's see, here's the create, here's the query, and here is the change car. The logic is pretty simple. All the function names pretty much describe what they are doing. So I can go in here and I can duplicate this code so that I can create the query all function, for example. In this case, for the query all, I don't need a parameter, so I can erase this from here. And instead of calling the get one from this model, these are built-in functions from Convector. You can do just get all and exclude this parameter. And there you go. Now you are querying all the data and it is going to handle all the data transformations. As you can see, if you do these things manually, you have to do all of this code, like turning all the buffer and transforming some strings and so on. We don't want to really do that, so we let Convector handle all of this for us. So we only have to do this. Another function that we need in here is the create function. So I'm going to copy the code again. And in this case, I need a new parameter, which is going to be of type car. Which is the one that I'm using right now, and in this case I want this property, this parameter to be called car as well. And when I want to save this, all I have to do is just do something like this, car.save, and there you go. With this we are creating our car. Since I am adding this parameter like this, if we don't meet the requirements from the model, which include read-only properties and validations and some required parameters, it's going to throw an error for us. I don't have to validate things in here. In the case of vanilla code, I will need to, for example, validate that all the parameters are included. I would also need to validate data types, which this example in Go is not doing. But I am doing it in here just by using the decorators in Convector models. And the last function that I need is the change owner. So I can do something like this, change owner, and I can also include in here, in this case, the ID of the owner. So I have to include this same parameter that I already had in here. I can just copy this one. And I'm going to need the new owner. In this case, I need first to retrieve this current entity, this asset. So I'm going to do something like this. And I'm going to include in here a new parameter, which is going to be a type string as well, to include the new owner. And I'm going to set it up in here. So here's the property owner. I'm going to include this one in here, and I can just return this and the property gets saved. So in these 3 lines I am doing the same as this Go file is doing in here. So I don't have to marshal data and so on. The only thing that I need to do is just query the card that I want to transfer and change the property to this new owner. And just like that, I have my controller ready to be installed in the blockchain. So this is pretty much it for the development of the smart contract. Now what I would need to do is to run this in a blockchain setup. So for this development blockchain, I'm going to use Hurley. Hurley is the new name of what used to be called dev environment. It is kind of an evolution, since now we have a spin-off that tool, in which we can create new development blockchain networks for us to test things and so on. And I'll also do the necessary things like installing or upgrading the chain codes. So in this case, I am going to spin up a new blockchain with Hurley, so I'm assuming that you already installed this. If you haven't, all you have to do is just type npm install g, and then you just type world/Hurley. And just like that, you will have this tool globally, and it is going to allow you to create your development without having to configure or set up anything. So for example, I can come in here and I can call Hurl new, and I'm going to tell this that I want 3 organizations. So I just type enter, and if you haven't already downloaded all the source code and the containers from Hyperledger, it is going to do that for you. Otherwise, it will ignore the download of the images and it will just go straight to setting up your development network. So it just takes a few seconds. By default, it creates 2 organizations with 1 administrator and 1 regular user, and also 1 channel, but you can change those parameters. It's really configurable, so if you need 10 organizations, you can tell the framework and so on. So there you go. It tells me that everything is pretty much ready. It tells me that the deployment is ready at this folder, and that I can see all the topology in here. It tells me that I have 3 organizations, an admin and a user per organization, and 1 channel called ch1. Now that I have just installed this development blockchain network, I can check it out doing docker ps, in which I can see that everything is set up for me and everything is working. So for me to install this controller, I need to first package it to turn this Convector smart contract into a package that I can actually install. The thing is that Hurley is not necessarily limited or dependent on Convector, so you actually can use Hurley to deploy Golang or Node, vanilla Node smart contracts. You don't have to use Convector to use Hurley. So what I'm going to do in here is I'm going to find the package JSON of this project, which is going to give me the instructions so that I can package the project. So what it tells me is that if you run shellcode package, it's going to come in here and call the shellcode manager. Shellcode manager is a piece of the Convector suite that allows me to, create the actual package that I upload to the blockchain. And it tells me that I have to pass 2 parameters. In this case, these 2 parameters are pointing to this config file. By now, Convector CLI already integrates with Hurley, so in this case, it is pointing these certificates and all the requirements like the network configuration to this folder called Hyperledger Fabric Network that is created at your root home. In there, you will have access to everything from certificates to configurations to scripts and everything that you need for your blockchain network. So I'm going to package this code based on these configurations, and then I will upload them with Hurley. So what I have to do, I just need to call npm run cc package, and then I'm going to pass 2 parameters. In this case, I want to pass that I'm going to use the car chain code for the organization 1. So there you go. Now we have this package. What this package is actually my chain code. This is the native development code that is going to be running on the blockchain. So the only thing that I need to do now is through Hurley, I'm going to install this to the blockchain. So I need to get inside of that folder since there is all the source code. And in here, what I need to do is just call Hurl install. And then I'm going to tell what is the name of this chain code that I'm installing. In this case, I want to call this fabcar, and the source code language. So now I have to put Node, which is the code, the programming language that I'm using. And this is going to go and read all the configuration from the blockchain that I created a few seconds ago, and using all the crypto materials that I also self-generated with Hurley. And there you go. After a few seconds or minutes, depending on your internet connection, if you have dependencies coming from npm, your chain code is ready to be used. Just in case you have to make a change in your code, you can pretty simply upgrade your chain code with Hurley. You have to change from install to upgrade and tell which one is the version that you want to use. In this case, I want to upgrade to 1.2. So I just click enter. Just let's imagine that I made some changes in my code, and it's going to do everything for me. It's also going to install it on each organization, and it is also going to instantiate and therefore bring down all the dependencies if that's needed. And then you go, now we have an upgraded chain coding in our blockchain. So this is it for this video. I just created a smart contract, I uploaded, I even upgraded the code. And for my next video, what I'm going to show you is how to reuse the Convector code into your backend, in this case a Node.js backend. So see you until next time. Remember to subscribe to our YouTube channel for more content like this one.